Okay. Yeah, so why don't we well actually yeah, Celeste, if you want to introduce yourself again, and then if you want to introduce Bennett and then I'll go after Bennett.
Yes. All right. So good evening, everyone. My name is Celeste, and I work at the New Haven Free Public Library in Ives Square. And we've been running this series for some time already with a learn to code and then build an app and now create a database. So I have Page as a software developer engineer, and we're going to have Bennett as a guest today, Bennett Graff. He is he works for a bigger database company, Gale, and I'm gonna leave it to you guys so you can introduce yourself.
Thank you, Celeste. So I'm going to, so my name is Bennett Graff. I am a product developer for a company called Gale, G-A-L-E, and it is a large builder of databases for libraries, primarily, all kinds, public libraries, academic libraries, and school libraries. I'm going to now share the screen so I can show you what I do for a living. And I'm going to start by hiding all these people and images. So we should start with where I work. I work at a company called Cengage. Cengage is a very, very large textbook publisher. It has a few thousand employees. It generates revenue of about $1.7 billion a year. It has a worldwide reach. It provides course materials of all sorts. And this is its landing page, its homepage. Very simple, but if you dig in, there's lots to see. And just even from the very opening, you can see it asks, are you an instructor or are you a student? So this is the parent company. The company I work for is called Gale. And Gale isn't a textbook company. It is a provider of information to libraries. And we work roughly in the same universe as Cengage, but we are a smaller component and we build lots of databases. Sorry about that. Please ignore my phone. And I'm going to show you a little bit of behind the scenes, not so much how we build the databases, but the way we think about databases, because I'm not a coder, but I am a product developer. And my role as a product developer is to figure out what do people want, how do they want it, and what is the best way to get it to them. So we're now a little bit in the back room in the Gale product menu, where you can see many of the databases. I'm just going to literally scroll so you can see how many different databases we have created. There's a few hundred here, to be honest. And they actually will fall into categories. I really like this dashboard a little bit because I can pick my categories. So I can see, I'm looking at all the databases right now, but we have databases that are just ebook databases, databases of periodicals and newspapers. They look like this. And we have the databases that I specialize, and I'll talk more about it a little later, are databases of important historical materials. Sorry, I had to get rid of that so you can see everything there. And there's lots there to talk about. And then we also have categories, databases by category. We have a particular strengths in literature and in business. And there's a special category called in context. It's just kind of a fancy term for databases that combine periodical content and books, but have really subject focuses in particular or serve a particular constituency. A subject focus might be Canada, or a constituency might be elementary schools. Or college here. So that's kind of the world in which I work. I have many colleagues who help build these kinds of databases. Just to show you very, very quickly the kinds of things that we are looking at. Sorry, look, it's already logged me out because I didn't stay in long enough, believe it or not, to actually look at these things. Let's take a look at one or two of these just to kind of get the feel of how these work. So let's go to the ebooks, and we'll go to this one called Gale ebooks. It's going to ask me to sign in because it automatically logged me out because I had not been busy in it. Hopefully it won't take long to actually sign me in.
It's okay. And I just want to say thank you so much for enjoying us tonight and like spending some time telling us what you do for work.
Sure.
Not from the coding perspective, but from the content, which
Yes.
is pretty cool, I think. Like, it's
yes.
really amazing.
We depend heavily on our coders. I mean, the way product developers and coders kind of work, and product developers have market research responsibilities. So we conceptualize products and how they're organized, and that comes about as a result of lots of conversations we have with users and some of the intermediaries. So we will speak to the students and the faculty who use these kinds of products, and we'll talk to the librarians who buy these products on their behalf. So we will do lots of market research. So this is a collection of ebooks. Libraries like to purchase ebooks, as you may well know. New Haven Free Public Library has its own available ebooks. The ebooks available from Gale tend to be a little more educationally focused. We don't do a lot of fiction. We do a lot of nonfiction. We do a lot of reference works, and the books we do tend to come in many different levels. As you can see, the front page kind of reveals a lot. We organize by subject, and then you can look at all of the front covers of all of the books when you dive in. Of particular interest for developers, and then in the end, for the coders when they actually have to dig in, is when you do an advanced search, of course, you can search for various important things. You can search among the keywords or for something in the document title, or just you can search the image captions, the description that accompanies all of the images, all of these kinds of phenomena. But one of the more interesting characteristics is how we categorize these materials. So one of the things we learned over time from our librarian customers, they said, and also from our educational customers, they said, very important, we really need to know the audience and the reading levels of the books. And when we dived into this kind of phenomenon, we learned that reading levels come in many forms, and so do audiences. So you might say, I really only want to look at titles for children's lower elementary. And then in terms of content level, this actually is kind of a reading level, if you will, describing the level of sophistication. We also have books in multiple languages, so we also want to let that be a filter, if you will. And then look at this, we have guided reading levels. These letters actually designate reading levels, and it's actually part of a system, as is this ATOS. Here's an interest level category. This actually is much more grade focused. And then there's this phenomenon called Lexile measures and Lexile indices, Lexile codes rather. Again, all of these are ways of assessing the level of the title. And actually, so that you can kind of get a sense of it, the little question mark here is a description of what is this particular assessment system that we're talking about. There's more than one, so we actually adopted several of them because different school systems use different systems. One system may use the ATOS, and another may be using Lexile. And yes, they are sometimes branded, frameworks. So that would be ebooks. If you're in the world of periodicals, and we amass lots and lots of periodicals in digital form, and then we do various arrangements of them. For example, these ones called one files, especially one called academic one file or the journal one file. Those are massive, massive databases with thousands of titles in them. But we do lots of breakouts because people say, look, I don't really need a subscription to thousands of titles. I need something specific, something that my people are asking for. like this one on culinary arts. And this will be a database comprising culinary arts related publications. If I go to the title list, it'll actually send me to a place where I can download this Excel spreadsheet. This is a description, and title lists are critical for librarians to have an understanding of, well, what am I getting when I subscribe to this product? What I love about these lists in particular is reading some of the really cool titles that you had no idea existed. And by the way, some of them will come from overseas, such as, the Australian Journal of Nutrition and Dietetics. Now that's probably a
That's
fairly
awesome.
What?
That is awesome. Like, that's pretty cool.
Yeah, but I love one called Baking Management, which is clearly a trade publication intended for people who are running baking businesses, and or BBC's Good Food. And many of them are magazines, but they're not just magazines. There's all sorts of content. And there is a whole division at our company that focuses on basically making contracts with all of these publishers to use their materials in these databases so that users can basically search for anything. I mean, alcohol, how it all adds up. Don't even ask me what it means. I mean, it's a monograph and it's a pamphlet. Monograph here means it's a book of sorts. And it's a wonderland of materials that's just remarkable to play in and search in. So let's go back to our list a little bit and look at the area I specialize in particular. I do this area called primary sources. This is where I work, where I do most of my work. And what I do is I take historical materials, important historical materials that don't have a digital form. And with a very large team, we convert hundreds of thousands, sometimes millions of pages of historical content into something that is searchable. Sometimes we focus on things like historical newspapers or a topic. This one is called Archives of Sexuality and Gender. This is a very important topic of study in many academic settings. Or we might focus on, we do materials in other languages. So we did a whole set of materials related to Brazilian and Portuguese history. We have a large series of collections devoted to the history of China and the modern world. In this case, China and the modern world means the history of late 19th century and early 20th century China and its relations with often Western powers. If you're into government publications, there are declassified documents that we do. We do British intelligence documents. Yes, this is MI5, James Bond style materials. Actually, it's the research work that they would have done over the years during World War II and during the Cold War. We also have really important publications where we do the complete run of it, such as The Economist. I happen to be a big fan of The Economist, but if you are more of the financial type, you have the Financial Times. A lot of what we do tends to be either international or often British focused, and you'll know some of those publications. We have a lot of legal publications. We cover a lot of areas. I'm going to show you just one item. And then after I show you this, I'm going to stop. And then I'm going to allow for questions if there are any. And if there aren't any, others on the call are going to take over. This is a collection that I worked on. It's the history of public health in modern America. It drew on collections that came from a variety of places. One important library is called the New York Academy of Medicine. It's in the Upper West, it's on the Upper East Side, and it has a vast, vast collection of materials, all related to the history of medicine, to the history of public health, and any topic that has anything to do with medicine, and they cover a vast array. We wanted to focus in particular on public health because, as we know, with Obamacare, this is a very, very important topic to people. And there are a number of scholars and students who, in tracking the debate that is occurring today, want to know, well, what did the debate look like before then? And so in this kind of thing, in this kind of product, we can look up, let's say we're going to look up Maybe we'll look up, let's look up influenza.
Hey, calling you, you don't answer.
So we're seeing some materials related to influenza and its history. You'll notice the different years. For example, here's influenza 1918 to 1919. It'll contain a series of documents about these are the years of the Spanish flu. And if we open them, which I'll do right now in a separate tab, you can actually see the materials that show up. It's a 91-page file that was in which all sorts of materials were collected related to the Spanish flu. For example, this document here, I'm going to shrink it down a little bit if I can. Here, a stern task for stern women. There is nothing in it. This is basically a notice going around for people to help. And this collection of historical material covers all sorts of topics. You'll notice, by the way, that the term I was searching on is highlighted on the page. Since it was the term I was looking for, it wants to direct me exactly to it. By the way, this is a fascinating bit of history. Here is the Spanish flu, and you're getting here a list of things you should and shouldn't do when you are out in public. And everything from don't spit on the street to cover up each cough and sneeze. And this material is absolutely fascinating, which is why I love this. Here's something about the flu 1927 to 1929. Now, why would there be a separate document related to this? Well, that is because, whoops, did I just stop the share? My mistake. Let me return to the share real quickly because of that drop down screen. Oh, I keep on hitting, please forgive. Things are located in funny places. I need to actually move my screen around just a little bit. Okay, there we go. All right, let's blow that up. So the flu from 1927, 1929. This is a very short file, but what's really interesting about this is the flu came around again 10 years later. And although it wasn't as bad as the devastation wreaked by the Spanish flu, it actually, many people died in the United States during that period of time, because the flu after 1919, a lot of people had already developed essentially immunity from having caught it. But as the flu travels around the world every year, and remember, there's no such thing as a flu vaccine yet. As the flu travels around the world, it changes, it modifies, it creates variants. And when it came back in 1927 and 1928 and 1929, it actually did some pretty terrible things in the United States, you know, killing tens of thousands of individuals. Here we have kind of a notice from the Department of Health for the state of New York. And here they're talking about how 24,000 cases were reported from 21 cities, 67 villages, and 50 of the 57 upstate counties. The flu wreaking havoc 10 years later after the Spanish flu. And this collection is endless for all of the kinds of things you could do. These collections are typical in that you would kind of stick a word in, look for materials, and see your results, and then start hunting through them to do the research you need. But we also have cool visual features too, such as this thing called the topic finder. Let's see how it
remember
works.
you're showing me. It's like pretty cool.
So let's take a look at what happens when you search for polio amid the 500,000 pages of materials that we've captured. And you see a tile, and what it's doing is it's basically doing a kind of subject indexing showing topics that are related to this. And if you actually click on one of these, it will probably blow it up. So polio, otherwise known as infantile paralysis, for which there was no vaccine until Jonas Salk created it in the 50s, was a major affliction for children's health. And if you blow that up, you can actually see other related topics. Here we're looking at the children's. This is the Children's Bureau for Health, which actually was a federal department, or relatedly, child labor. Child labor laws were only coming into place. So considering the fact that children were not protected by labor laws, they could be exposed to polio because they were basically going to factories. The other thing that's really kind of interesting is when we're not using the topic finder, which is visually beautiful, another tool we can use is what we call the term frequency chart. I really like this one. What it does is it allows you to see how often a term shows up in the literature of the time. So let's do polio again, and let's search for what happens. And here we're getting a sense of how often this material is getting discussed. It's indicating the number of documents that the term polio actually is showing up in. But, you know, for example, this seems very high. This could be, 48 documents. It seems like a lot, certainly a lot more than, the one document in 1985. But then again, maybe there just isn't a lot of 1985 documents in this collection. So we also can check how often it's appearing percentage-wise. This gives us a truer sense. In addition, we might want to alter things about it. For example, it says 1800, 1997, but I know that most of this collection actually is from 1890 to 1970. I know because it's in the title of the collection. So let's actually reduce the scope of it and get a much better sense of what are we talking about. And now we have a sense, polio is really in the news at the time with these, in the 1950s, which makes a lot of sense because that is when the vaccine is actually being developed and deployed. So this kind of word frequency, term frequency counter is a really useful tool if you're doing analysis of historical documents and you want to get a sense of what's getting talked about and how much. And you could do comparisons. So I might add a row and say, well, how about compared to influenza? What's getting talked about more? Okay. So now we actually have a real interesting comparison. Black is influenza, blue is polio, and polio is getting talked about a lot more in the 1950s than than influenza. Even though we know influenza comes around every year, but polio is getting more attention. Again, something very valuable for scholars if they want to get a sense of what is, if you will, how are things ranking in terms of what's getting talked about, what's the object of study. So these are just some of the tools that we use. I'll show you one last thing that I'm not going to even demonstrate. It's just more of a, let's just say it's a teaser. And that is this really cool thing that we created called, it's called the Scholar Lab. And someday, if there were enough interest, it would be great to show this because this is the lab we created for doing big data analysis. And this allows you to really dive in and kind of analyze data in all sorts of ways and use all sorts of tools. For example, and what's really neat about it is the tools that we use, they come in many different types and you kind of have to be fairly expert in understanding them. Things called document clustering or named entity recognition. Every one of these could be described. N-grams. You can analyze parts of speech. There's a tool for what's called sentiment analysis or topic modeling. These are all known entities for people who do big data analysis. And we've created a lab that lets you take the kind of content I just showed you and to make use of it in this little lab. So you can actually kind of pick more specifically which kinds of things you want to look at. I'll stop here. This is kind of a quick tour of the kind of work that Gale does and kind of an extension of what do product developers think about when they're building the things that they think their customers need. And I'll stop the share and I'll let Paige take over.
Thank you so much. It was great having you, and stick around if you want, or if you have something to do, you can go. And I just want to say, I mean, I'm kind of on like in the middle, and I can see in my head like the information like crossing over and seeing from the other side when we may be talking about select, or like the filter will be like a select, or like the different tables when we're talking about placing the information. So I will have Paige do now the rest of the work, but thank you so much.
You're very welcome. And just so for the coders out there, everything is made possible by the phenomenon as metadata. And we build all of our content in XML formats, and we make use of DTDs, document type definition. So, the coders are back there kind of doing their work, and then they will use their scripts to get the category, the department, we refer to it as content engineering, quite literally. And they're the ones who will take the content and then figure out how to deploy it into this platform that we have both built and probably, subcontracted from off-the-shelf software developers who have the tools that we need. I'll stop here, and Paige, it's all yours.
Yeah, that was really, really fascinating, Bennett. I haven't come across a lot of data sources like that, especially stuff online that's collecting like literature and source material like that. So that's really, really cool to see, especially the in-text search, all those indexed items from the PDFs of actual historical documents. That's really cool. Yeah, super fascinating. Okay, so I'll go ahead and get started with today's session that I had planned. Let me go ahead and share my screen as well. Okay, so today's session hopefully kind of gets you a little bit closer to managing something that I might call like a micro version of what like Bennett was kind of demonstrating. So these, these databases that contain information that we would want to see as a user or as a developer. So hopefully at this point, we'll now have enough tools together from the last two lessons and this one included to kind of build a database for ourselves. So and we're going to do that today. We're going to create a sample, very basic database with some data in it. And we're going to build a script that will allow us to do that again and again, time after time, that we can then edit and modify depending on the type of data that we want in that database. Just to reiterate, if you go to this GitHub web URL, which we've been using for the class so far, you can go to github.com/Page Swanson, and then you'll see this library SQL repository once you land there. And then if you just go to lessons, you can follow along with me if you want to. We're going to be on session 4 today. So that's June 28th. Is today the 28th? Oh, it's 29th. That's okay. Just a reminder, again, I have office hours every Monday, 6:30 to 8:30, and then you can email me here if you have any questions before that session comes up. So we already talked to Bennett, talk about his work that he does with databases regularly, and then I'm going to introduce this term called schema, and the data definition language, that part of SQL or SQL. So basically, how do we use SQL to make database structures or schema? And then just talk a little bit about what we're going to try to do to make a script, which basically is going to automate a lot of this creation of schema for us. So what is schema? I have a link here just to Wikipedia, which talks about like what database schema is, but effectively I pulled this quote. It actually comes from the Greek word for shape. So schema is like the shape of something, and generally it's the structure described in a language supported by the database management system. So that's a little bit esoteric sound, or it's a little bit formal sounding, but basically it's just a blueprint of a database and how it's constructed. And for a relational database, which is what we're working with in SQL or SQLite specifically, that's divided into database tables. So basically, it's just the organization of all the database tables in your database. For SQLite, for using SQLite, we've been using a couple different applications. We've been using DB browser, which actually I'm going to close and reopen so that we get a fresh session. We've been using DB browser, which I think is great for modifying SQLite. And then I also introduced last week this SQL Online IDE, which I really like a lot. If you just go to SQLiteOnline.com, you can see this this tool. And I really like it because it's online. You don't need to install anything, and you can immediately start using SQLite. But in either of these cases, going back to my lesson here, if we want to view the schema that I'm talking about, like how do you look at this? In DB browser, it's going to be this database structure tab. You can also go to tools, or sorry, view. Wait. Oh, too big. I guess it's fine that it's that big. Preferably, I'm not even going to use this. I'm actually going to start using SQLite Online because I like it a lot. So anyway, you can use this database structure tab. There's another way to view it too, but we need to actually make our database first before we can view that other view for looking at our schema. Let's stick to this though, SQLite Online, because I know everyone can access this. There's no question. Even if you're a little bit behind in the sessions, you can just pull up this web page and you can get started right away. So let's do that. Our schema is actually going to be here on the left-hand side in this view. So here, our schema, our database, I think is actually just technically our database is called table here. And then this is a table within that, so it's called demo. I'm actually going to drop this table, which is something we're going to get introduced to later. This idea of dropping a table. But what that's going to do is delete the table. So now the DB is empty. So that's where I want us to get started because we're going to try to start from scratch with this script that we're going to make. So the first thing we want to consider when we're putting a schema together, which I think is kind of what Bennett was talking about a little bit when his team is making a consideration for like they have all of this data that they want to work on or that they want to build a product for, but they need to organize that data in some useful way to their users, or specifically like thinking of librarians or teachers or something like that. They want to use that data in a particular way, and so it would be helpful if the developers or engineers or the product managers, product developers, they organized the view of the data such that it's most useful to the people that are going to consume it. So we want to do the same thing for our database. We want to figure out how we want our data to look, our example data, and we want to build tables that are meaningful to us. So let's get started doing that. First of all, the most helpful thing you can do in this scenario is actually look at the data that you want to use. So what I've done is I've actually built the, I've lost my part of my statement here. I'll have to edit that in post. Sorry about that. Yeah. So above this, there should be an insert statement, but that's okay. We'll go ahead and add that now. So what I'm imagining, first of all, is an insert statement to kind of represent the data we want to have in our table. I mean, what better way to do that than what data you would like to put in the table that you're imagining? So really what we were missing here is just insert into the name of our table, which I'm going to call bottle info. So this table is basically just something I've imagined. It doesn't exist yet, but we're going to create it, and we're going to create it according to this insert statement. So there's going to be a table. I wanted to call it bottle info because I'm going to store info about bottles. We're going to want an ID for each bottle represented in the table should be, unique, because we want to be able to distinguish bottles from other bottles. I think that this bottle should have a color. It has a type of like construction, like what it's made of, and it has a volume in milliliters. And I had an indication as to whether or not the bottle is clear. I was actually thinking about this bottle when I did this. So I have an entry for this bottle here. It's a green bottle. It's made of glass. It is 1,000 milliliters or a liter, and it is clear. Or really what that means is see-through, but maybe we'll make a modification to that. Maybe we don't even really need this piece of information, but that's something that we can figure out along the way. So if I try to run this, it's not going to work. And what it tells me is that there's no such table bottle info. So let's get started doing that. Let's start making our schema. And the first thing we'll do is create a table. So if we want to create a table, we have to follow a pretty simple strategy for doing that. I've provided basically the SQL or the SQL script code that you'll need to use in order to do this. And the syntax is very simple. You need to know a couple of things before you get started. You need to know the name of the table that you want. You need to know some of the columns or the pieces of data that we've talked about in previous sessions that we're interested in when we look at a table. So I've chosen ID, color, construction, milliliters, and is clear as my columns and their names. And then I need to know the data types for some of these columns. So I linked here, by the way, the syntax for this create table script here. But I also linked some information about data types in SQLite. A data type is basically a piece of information about a particular column or a particular attribute on a table. That information is important when we start to query on a table for that information stored in the column in that table. So if I want to work with data that I want to do like arithmetic on, like if I want to add some numbers, I want to subtract some numbers, I need to be working with certain types of data. So for SQLite, I could work with numeric data. I could work with what's called like real data, real numbers. I could work with integers. So integers would just be like 1, 2, 3, 4, 5, 6, 7, 8. A numeric, that's going to be basically data that's not necessarily best described as an integer or a real. It's more like dates or times, things like this. And then a real would be like typically like represented as like a floating point number. So like 1.823 or 57.54, something like that. So we're going to keep it very simple. We're really only going to work with integers and text because we don't need our table to be too complicated for this bottle information. So what I said is basically, I want to create a table if it does not exist. So this is going to help us avoid like an error if the table does exist already. And basically what this means is that if the table already exists, it will stop right there. It's not going to make this table again. So that way we won't experience an error if we need to run this script multiple times, which can be useful if we want to reset, for example, our table. Let's say we made the table, but we make some changes we don't like. We can run our script again, and it'll make this table, but it won't throw an error if it already exists. And then I named the table here, so I called it bottle info. And then I gave it some columns. So I gave it an ID, which is an integer, which matches this data type here. So these are more granular data types that are available with other database languages or like frameworks. Like you might have heard of like MySQL, or you might have heard of like PostgreSQL. These are available in those database languages, but for ours, SQLite is a little bit simpler. It keeps things a little bit more basic. So only these are available here. So that's just to help explain kind of what these are. So we're going to use an integer for the ID, because if I'm looking back at my insert statement here, I have some integers. So that I'm lining that up with this. So you can see here I'm going one by one. So color is here. I'm going color. Construction is next. Volume in milliliters is next. I used a real here, actually, because even though we don't need a real, we're just using integers. Maybe we have a bottle that's, half a milliliter. It's not really necessary for us to use a real, but it's just to mix it up a little bit. And then is clear, which is a text piece of data. So I have just a text piece of data right here. One thing to note is that I added this keyword here, primary key, to this ID column. What that means is it's actually a requirement for SQLite. When you're making a table, you need to select a column that represents the primary key of that table. So you have to have this primary key. And what this means effectively is that this column can be used to uniquely identify a piece of information in the table. And it also means that we can't duplicate any records. We can't duplicate the value of this column for any of the records in our table. There's ways to get around not having a primary key. You can have something called a row ID to get around that. But for simplicity's sake, we're going to make ID our primary key. And that means we can uniquely refer to these bottles. So bottle 4 is always going to be this row. We can't have another bottle with ID 4. That's kind of all that means. So let's actually run the script, this piece of the script. So what we're going to do is we're going to, we'll just delete this and we'll paste it here. So create table if it doesn't exist with ID, color, construction, volume, and is clear. So I'm going to click run. Okay, so it shows me here in the history that it was successful. It wasn't like this, right? No such table. Now the table exists. And if you look over here on the left-hand side with the schema view that I talked about earlier, you can see the table that we just made. And it has all of the columns and all of the types of data that we're working with for those columns. It also has a little key symbol for the primary key on the table. So now what we can do is undo. I'm going to undo, like Control Z, and I'm going to go back to my insert statement, and we should be able to run this. And it worked. It was successful. So learning what we did before in our last sessions, and if you're not sure what I'm doing here, that's okay. I have all of that information stored. If you go back to the top here and click lessons, you can see the previous lessons kind of explaining what a select statement is. But basically, I'm going to try to look at the table now. I'm going to look at the data stored in the table that I just added with this insert statement. So I'm going to run and look. We can see all of the data that we just added. If I go back to this tab, we can see it totally lines up with this data that's right here in this insert statement. So you can see there's a green glass bottle that's 1,000 milliliters. It has ID 1, et cetera, et cetera, et cetera. Okay, so we're moving right along. We now have a table. Well, we have schema, which consists of a single table with multiple columns on it. We can select on those columns and we can see the data in our table. So this is already getting pretty useful at this point. Okay. Oh, not to mention, of course, the key part about this statement is that it includes this little clause. This is the clause right here. So it's called a clause. This is the SQL statement, and this is a clause in that statement. So if not exists, lets us run this over and over and over again. But it won't fail. It won't fail any of these times because it checks before it tries to make the table. And since the table already exists, it does nothing. So it doesn't reset the table or anything like that. It just keeps all of the information in the table. And by the way, if you're using this website to kind of keep up, you'll notice I'm like completing statements. I just do that by pressing tab. So it'll recommend a statement to me. and I can just press tab or a keyword, and it'll let me complete statements quickly, but it's helpful if you're like learning to do that. So I can select, and all of my data is still there because it didn't recreate the table or anything like that. Okay, so we did our create statements so that we have schema now. We added our data types to our columns. Okay, so now what we can do, we can try modifying the schema. Yeah, let's try modifying the schema. So let's say we ran our create statement, but we messed up a little bit. We fudged it, and we want to update one of our schema objects that we created and change it or modify it a little bit so that it works or behaves a little bit differently. It's configured differently. You can always use alter statements like the one I'm about to show after the fact. Like you can use them after you've done your creation. So this is a particular alter statement that's provided by SQLite. It's called alter table. So this alter table statement comes in a couple of different forms. You can modify information about a table or the schema for a table with this kind of statement. So you can do a number of things. An obvious thing would be renaming the table, but you can also modify in column data. So I'm going to try to modify, or I'm going to add a column actually, like it's specified here in the documentation, because I realized that I forgot a column when I first made the table. I wanted to indicate where the bottle is manufactured. I'm just fabricating a situation here, but you know, there's tons of situations where you might come back later and you revisit the schema you've made and you want to make additions to it. So all I need to do is I need to know what the name of the column is going to be, and I need to know the type of data that I'm going to have for that column, and of course I need to know the name of my table. So I'm just going to copy this here. I'm going to go back to my editor, and I'm just going to paste this in. So alter table bottle info, so this table, and I'm going to add a column called manufactured where. So and it's going to be a text column. So I'm going to run this. Okay, it ran successfully. If we select again from the table, bottle info, and run this, we see our new column. I mean, we can also see it on the left-hand side with the schema view, manufactured where, but it has null data. This is because we didn't add any data for this particular column yet. We've just, we've only added the column to the table. So it's there, but there's nothing in it. And that's what SQLite will do by default. It will add the column with just empty data. So no content at all. And then we can also do things like modify the name of a column with this alter table statement. So maybe we realize that our construction column should have a better name, or it could have a better name. I don't really like the name construction. I think it could be shorter and simpler. I want to call it material. So similarly, I can copy this statement. I can paste it in. So I'm going to say alter table bottle info, but this time I'm going to rename a column instead of adding a column. So I'm going to rename it from construction, so you can see construction here, to material. So if I use a name that isn't there, it just won't work. It'll fail. It says there is no column called whatever that is. But if I use construction, I run this, it's going to update the schema. So now there's no longer a column called construction. The column is called material. And if I select again, so this star just means select all of the columns in the table. Select all of the data in all of the columns from this table. This just means all of the columns. And then the absence of a filter or a where statement, which we've talked about in the past, is saying select all of the data. So I'm just getting everything. And you'll see that the data is still there. Like it didn't remove any of the data in that column. It just changed the name of the column to material. Okay, so we can now modify data on a table. So what about doing something a little more drastic? What if I want to like completely undo a schema change, or I want to remove an object, like get rid of an object? that's part of my schema. So that's where the drop keyword comes in. Different implementations of SQL, like I mentioned before, like MySQL or PostgreSQL, which I talked about in the first session. They have different ways of structuring this query or this statement, but for SQLite, there's two different ways that I'm going to introduce today for dropping data, and it's the main types of data that I would think you would want to remove or get rid of. So this is different, by the way, than using a delete SQL statement, excuse me, because deleting data just means that we want to remove entries in a table. So like if I wanted to remove these rows, right, I would run the statement that we've seen in our previous sessions. It's just delete. So delete from model info would let me delete all of this data. Okay, but it's not going to do anything to the schema. The schema is still there. Model info is still there. I can still select from model info. It's just not going to give me any data. There's not going to be any data to show. But it doesn't mean that the table is gone. The table is still there. We could insert into it and get all of that data back. So maybe I can do that right now. Well, I'm not worried about it. We don't need the data necessarily yet. We're going to add it back in later anyhow. So if I wanted to drop the table altogether, completely drop it, I would use this statement. So I'd use drop table. I have a similar little clause here called if exists, which just says that if the table exists, you should drop it. If it doesn't exist, don't fail, like don't cause an error. So if I just do drop table model info and I run this, it's going to drop the table. The DB is empty. But if I run it again, it's going to fail. There is no table called model info. But if I add this if exists clause, I can run the statement again and again, and it won't fail at any point in time. So what I want to do now actually is, whoops. Well, I can't undo it, can I? That's okay. We'll grab our create from before. Anyway, you can, if you're using DB browser, if you're following along using DB browser, you can just revert like we've done in the past. But on this interface, I don't think you can just revert. So we gotta start fresh. So I'm gonna run my create table again to get my table back. It has the old column because we didn't update this create statement, but that's okay. I don't really mind. For removing a column, we have a different statement here. I'm not going to go into that because we are running out of time. We only have like, well, we're out of time, but I do want to share one last thing. I want to bring all of this stuff together into one script that you can run over and over and over again. So now that you're at this point, you can start databases from scratch with this kind of information. So I think it's really useful. But basically, you can follow this section here if you want to know about dropping a column. Let's say you added a column that you don't want anymore. You can run this kind of statement to drop a particular column, like remove it from the table. So if you want to do that, you can follow this part. But now that we have all of the data that we want, if I hadn't dropped the table altogether, the table would still be here in the form that we want it in. But let's go ahead and like conform it to that a little bit. So basically, what we want is a column called material instead of construction. And then if we had followed from before, we have a manufactured where column. And then I also, in the section just before this, I actually dropped the is clear column. So now we just have these 5 columns, okay? So we drafted our insert statement a little bit to match this new schema. And now in total, what we have is this. So I'm actually going to need to drop the table too, because it already exists. And although it's great that there won't be an error, I want to change the schema of the table. So the quickest way for me to do that really is to just drop the table altogether. So drop table if exists, because we don't want to throw an error if it doesn't. That's a great scenario for us if it does exist, because we're trying to write a script that we can run over and over and over again. So if the table doesn't exist already, that's fine. Just skip the statement and move on to the creation. But if it does exist, then we can drop it. Since we have the statement before, we don't really need this anymore, because it'll never exist if the drop is successful. So, and then at that point, we can insert into the table. And I'm going to add semicolons, which you use in SQL to indicate that the end of the statement is reached. So this is the sum total of all the work we've done. It was very, very fast. It took no time at all. You can see it ran the script. And if we take a look at bottle info, it has all of the columns that I've specified here. And if we, let's open a new tab actually, because I want to keep this up. But if we select from the table now, we can see it has all of the data that we added, including the manufactured where column. So this is like US, like United States and Italy and Mexico. These are all the different kinds of bottles. This one doesn't have a color. Yeah, so that's kind of concludes the session. And I have a copy of the completed script, which you can see here. So that's included. It's ready to go. It's all formatted. So you can use that yourself at home. If you don't want to have to remember all of this and flesh it all out by yourself, you can always use this script to get a table set up immediately. And you can modify it to your taste to include the columns and the types of data that you want. And you can get started making your own database and tables, and then just refer back to the previous sessions for how to add new data and select data and query different data. Yeah, so that concludes the session. I just want to note that next time, I'm really excited because I think this is going to be the most interesting part of the series. We're going to try to connect the database to an application. So we're going to set up an application. I think what I want to do is a small website, and we're going to try to get data from our database. So hopefully by the time that the series ends, you can set up your own website, a simple website. You can connect it to your database. You can add data and be good to go. So thanks everyone for joining. All those on Facebook Live as well. And thanks to Bennett for joining us today and presenting some information about what you do daily at work.
Thank you so much, Paige. And I lost internet for a second, but I'm back. So everything was good. Again, thank you both. Thank you, Paige. Thank you, Bennett. And see you in 2 weeks.
Yep. Thanks, everyone.